In the previous videos, we talked about quadratic functions. We talked about type A, which is y is equals to ax squared plus bx plus c. Then we also talked about type 2, which is a into x minus p all squared plus q. Then now in this video, our objective today is to check type 3, which is y is equals to a into x minus x1, then x minus x2. So this is our objective for today's lesson. So from this equation, we already know the effect of a, that a determines the shape of the graph. If a is greater than 0, smiley parabola. If a is less than 0, a set parabola. So in this case, x is just a variable in this function, because actually this is y of x or f of x. So it means that this function is a function of x. And then now we have x1 and x2. So x1 and x2, the two, they determine, or they tell you about the x intercept of the graph. So basically, when you see this equation and when you see x1 and x2, you just know that these are the x-intercept on the graph. So in order to apply this formula, you will be given a graph. You will be given a graph which is sketched, okay, or drawn according to scale, or even if it's not drawn according to scale. So if you are given a graph, and from that graph you are given the x-intercept, if you're given the x-intercept and at least 1 point on the graph, then you can determine the equation of that parabola. If and only if you are given two intercepts, two x-intercepts, and any point on the graph, it means you'll be given three points on the graph. The 2 points are the x-intercept, and the other point is the point on the graph. Whether it's a y-intercept or it's just any other point on the graph, then you can use this formula here in order to determine the equation of your parabola. All right, so let's check equation so that we get to understand and apply this type 3 parabola function. We're given s, and the coordinate of s is -2 is to 0, and then we're also given t, which is 6 is to 0, and they tell you that these are the x-intercept of the graph of f of x given by ax squared plus bx plus c, and then r is the y-intercept. So the straight line through r and t represent the graph of g of x, which is -2x plus d. So when you check this, when we analyze this, you can see that we're having two functions here. We're having a parabola and a straight line graph. Observing this parabola, you can see that this is a set parabola. It means that the value of a should be less than 0, or we should get a negative value of a when determining the equation, because it's a set parabola. And then when you look at this parabola, we are given the x-intercept, which is point t and point s. And the other point on this function or on this graph is point r. These are the points that lies on the function of f of x. And then when you observe the straight line graph, because I told you that you observe from the left going to the right, you can see that this is decreasing. And when the function is decreasing, we know that the gradient of this graph should be negative. And indeed it's negative, because g of x is given by -2x plus d. All right, so let's check on the first question. The first question says determine the value of d. Determine the value of d. From the graph, we don't see the value of d, but when we go to the equation, of g of x, we see that we are given g of x is equals to negative 2x plus d. So we have to determine the value of d. Then the question is, how are we going to determine the value of d? If you are given a function y is equals to mx plus c, and you already have the gradient, which is negative 2 plus c, then how do we get the value of c? We know that we are going to take any point on this line, on this straight line graph, and substitute it to x and y in order to obtain the c value. So from the straight line graph, we can observe that the only point or the only coordinates are the coordinates of t, which is 6 is to 0. 6 is to 0, right? So it means we're going to substitute these coordinates on this graph, meaning that when we see x, we're going to put 6. When we see y, we're going to put 0. Then our equation becomes 0 is equals to negative 2 into 6 plus c. Then we multiply out, we get negative 12 plus c. Then making c the subject of the formula, c is equals to positive 12. So it means the value of d is equals to 12. Our value of d is 12. All right. And remember something from the lesson of linear function. We told you that the value of c determines the y intercept. The value of c determines the y-intercept, which is d in this case. So the value of c in this equation is represented by d. So it means the value of d represents or determines the y-intercept. And as you can see, our y-intercept here, our y-intercept is point r. It's point r. Then it means our point r here, it's 0 is to 12. So we already have the coordinate of r, because they told us that r is the y-intercept, right? So now we have the coordinate of r. By just determining d, we already have the coordinate of r. Then the second question says, determine the equation of f in the form ax squared plus bx plus c. Then we are given the 2x-intercept and a point on the graph, or the y-intercept. So this can be done in two ways. We're given the 2x-intercept and the y-intercept. So if we're given 2x-intercept and a point on a graph, we know that we're going to apply this formula in order to determine the equation. We say y is equals to a into x minus x1, then x minus x2. Then y should be equals to a into x minus. Then our coordinate of the x-intercept is s, which is minus 2 is to 0, minus 2 is to 0, and then t, which is 6 is to 0. Then when you plug these in this equation, these coordinates in the equation, we plug each coordinate, each x coordinate with its sign. Then it means we're having negative 2 here. We're just going to open bracket and put negative 2. Then x minus, this was positive 6. It means we're just going to put 6 here. And then we can try to simplify this. Y is equals to a into x. And then negative by negative is positive. And then this side is x minus 6. Then when you reach this step, because you already used the 2 points, then we are left with only 1 point, which is point r. then we're going to use point R, which is 0 is to 12. So when you use this point R, we know that this is X and this is Y. So when we see Y, we're going to put 12, and then when we see X, we're going to put 0. And then we're going to solve for A. The aim is to solve for A on this step. Then it means we're going to have 12 is equals to A into X. Our X value is 0 plus 2. And then we're going to have 0 minus 6. Then we're going to have 12, which is equals to, then when you work your algebra here, you're going to have negative 12. Then we multiply that by A. Then we can divide both sides by negative 12. We divide both sides by negative 12. Then our A value becomes negative 1. And in the beginning, I said that the value of A should be less than 0. Why? Because the parabola is a set parabola. Then it means the value of A indeed determines the shape of the graph. Then when you have found the value of A, you are going to take this value of A and go back here on this equation now and substitute the value of A and then expand this equation. Then it means you are having Y is equals to minus 1 into X plus 2, then X minus 6. Then we're having negative 1. We can multiply the bracket out. We're having X squared minus 6X plus 2X minus 12. And then we can add the like terms inside the brackets, and then we're having X squared minus 4X minus 12. Then we can multiply by this negative. We're going to have negative X squared plus 4X plus 12. Then this is your function of this parabola in terms of ax squared plus bx plus c. So we have solved for this equation, or for the equation of this parabola. Or someone can choose to use a different method on this situation. Remember, we are given the 2x intercept and the y intercept. So we're given what? We're given 2x intercept and 1y intercept. So if you're given that, remember the 2x intercept are s and t. S, which is minus 2, is to 0. Then the value of t, which is 6, is to 0. Then our y-intercept, which is r, which is 0, is to positive 12. If you are given 2x-intercept and the y-intercept, or if you are given any 2x-intercept and a point on the graph, if you don't want to use this method, you can choose to use, because they said to you, determine the equation in the form ax squared plus bx plus c. You can use the same formula in order to determine the equation. We say y is equals to ax squared plus bx plus c. We are having 2x intercept. So we are going to substitute the coordinates of the first x-intercept on this equation. Meaning that this is our x, this is our y. Where we see y, we put 0, which is equals to a into negative 2, then squared plus b into minus 2, then plus c. Then we are going to have 0, which is equals to 2 squared, it's 4, then it's 4a minus 2b plus c. And then now you remember that the value of c determines the y intercept. Determines the y-intercept. So it means this is the y value. And our y-intercept in this case, we know that it's 12. So we're going to substitute. Where we see C, we're going to put 12. So it means our equation becomes 0 is equals to 4a minus 2b plus 12. All right. Then we are having the first equation here. This is our first equation. And then now we're going to substitute the second set of coordinates into the very same equation. All right. Then we're having y is equals to ax squared plus bx plus c. Then our y value is 0, which is equals to a into 6 squared plus b into 6 plus our c value. We know that this is the y-intercept, and then this is positive 12. Then when you simplify this, you're going to have 0, which is equals to 6 squared is 36 multiplied by a, it's 36a plus 6b plus 12. So this is your second equation. Then in this situation, we are going to apply simultaneous equation. So we can take equation 1. We're going to say from equation 1, which our equation 1 was 0, is equals to 4a minus 2b plus 12, and make at least a or b the subject of the formula. Then I choose to make a the subject of the formula in this situation. Then when I make a the subject of the formula, it means I'm gonna have to take negative 2b and 12 to the other side. Then it means I'm going to have 2b minus 12, which is equals to 4a. Then I divide both sides by 4, Then now a should be equals to, when you divide this, you're going to have 1 over 2b minus 12 divided by 4, it's 3. Then this is your equation. This is your equation 3. Then you're going to do what? You're going to substitute equation 3 into equation 2, simultaneous. Then our equation 2 is here. It's saying 0 is equals to 36a plus 6b plus 12. So it means where we see a, we're going to substitute half b minus 3. Half b minus 3. Then now it means we're going to have 0, which is equals to 36. Then the value of a, we put half b minus 3 plus 6b plus 12. So 0 should be equals to 36 multiplied by half, it's 18. Then multiplied by b, it means we're going to have 18b. Then 36 multiplied by 3, by negative 3, it's negative 108. And then plus 6b plus 12. Then we can add the like terms here. Then we're going to have 0 is equals to, when we add 18b plus 16b, we're going to have 24b. Then we add negative 108 by 12 plus 12, and then we get negative 96. Then we take 96 to the other side, it becomes negative 96, it becomes 96, which is equals to 24b. And then we divide both sides by 24. We can divide both sides by 24. Then our b value becomes 4. So we already found our b value. In order to obtain the a value, we're going to substitute. We know that we substitute the value of b into equation 3. Then our equation 3 was saying a is equals to half b minus 3, half b minus 3. Then a is equals to half of 4 minus 3. Then our a value becomes half of 4, it's 2, then minus 3. Then our a value becomes negative 1. So we know the value of a, we know the value of b, and we know the value of c, which is 12. So now we have to compile everything. It means our function, which is f of x, can be given by negative x. The value of a is negative x, it's negative, and then we have x squared. Then the value of b is positive 4, then we put x, then the value of c is plus 12. So it means this is your equation in the form ax squared plus bx plus c, in that order. You see this equation correspond with the equation that we found here using a different method. So you can choose the method that works best for you, and then the rest shall fall. So the third question says, if your function f of x is given by negative x squared plus 4x plus 12, then calculate the coordinates of your turning point. So you can see that this equation of f of x is the same one that we got in the previous question. So now they want you to calculate the coordinates of the turning point. So we know that to calculate the coordinate of the turning point of a parabola, if you're given a parabola like this, then we know that we should find the x coordinate, which is the axis of symmetry, from this equation by saying x is equals to negative b over 2a, and then our b value here is 4. It means we're going to have negative 4 divided by 2 into our a value is negative 1. Then when we solve this, we have negative 4 divided by negative 2, then which we have positive 2. Then this is your x turning point. Then to obtain the y corresponding value for this, then we're going to say f of 2 is equals to, then wherever we see x we put 2. Then our equation is negative into, then we're going to put 2 here, then square plus 4 into 2 plus 12. Then when you simplify this, you get that this is 16. Therefore, it means your turning point, therefore it means that your turning point, the coordinates are 2 is to 16. Then you are done with that question.